Let's go ahead and begin. In 7.4, we are going to start measuring angles. And so our essential question is, how do I write and measure angles and do problems with angles? So let's talk about angles. Angles are made up of a side, then a vertex, then a side. Side, then a vertex, then a side. Side, vertex, side. So when we talk about an angle, we have to label it in this order. It has to be a side, then a vertex, then another side. Let me draw you an example. If I have an angle, let's go ahead and draw a quick angle for a second. I'm going to use the side of a ruler just to make it look a little bit straighter. You're going to have a side and then a vertex and another side. I'm going to have an angle here, and I'm going to call this side M. I'm going to call this side R. And then I'm going to call this, I'm sorry, that's not even called a side, it's called a vertex. And then this side, which we're going to call a P. Technically, angles are made up of two rays with a common endpoint. And so I'm going to write that down. Two rays with a common endpoint. And I'm abbreviating endpoint. So I have this ray RP. And I have this ray, which is ray RM. It's two rays with the common endpoint. The common end point is called the vertex. The common end point is called the vertex. Think of the vertex as the middle of the angle. So I'm going to write that down. It's the middle of the angle. The way we write this particular angle, since we need to write it side, vertex, side, is we have to pick something on the side of the angle. If we're talking about this angle right here, we pick a side, then the vertex, then the side. We could say, and we use this angle symbol like this. Angle, M, R, P. That's how we write it. Side, vertex, side. It has to be in that order. This is the same thing, is congruent to, is there another way I could write it in a second way? Angle, don't forget the angle symbol. Angle symbol. And it's the same angle as angle P, R, M. These two angles are exactly the same thing as each other. How come? Because whatever this angle measures is going to be the same whether I go from this side to this side or this side to that side. I could prove it to you by using a protractor. I could measure from this way up here and get like, oh, it's 58 degrees. And then I could go over here and measure and go this way and say, oh, that's about 58 degrees. It's the same whether I go from this side to this side or this side. That's going to be the same. It doesn't matter. That's how we do problems like this with angles. Okay? Angles are made up of side, vertex, side, and so this is how we write it. There is a rare case that sometimes, if there's not more than one angle, you can use a single letter. Okay? If there is not more than one angle, you can use a single letter. So in this case, if there's not more than one angle, you can use a single letter. This is one angle. I only see one angle here. I can use a single letter. That single letter has to be the vertex. So I'm going to put here vertex because that's what it needs to be. What is the single letter what's the vertex called? This is angle R. Sometimes in order for me not to know that this is an angle symbol, so I don't get confused that it's an L, I use this angle with a little arc on it. It means the same thing. It's an angle R. Sometimes you're going to make your angles like this, but sometimes I look at those and those look like L's or less than symbols, and this angle has a little arc on it. Sometimes I'll write it like that, and they mean the same thing interchangeably. Okay? So let me give you one more example that looks like number 3. Number 3 on our worksheet. Number 3 on our worksheet looks like this. J, K, M, and L. Then there's a number 1 right here, like this. Then it actually has this angle right here, just like this, and it's kind of shaded just a little bit. So I'm going to shade it for you guys. The direction is going to say, name the shaded angle. Okay? So let me read this and make sure you understand this little blurb that we wrote down right here. If there is not more than one angle, you can use a single letter. When you look at this angle, and we're talking about this one, you cannot call this angle K. The reason why you cannot call this angle K, because we don't know if we're talking about this angle or the big angle or that angle. Angle K is not specific enough. There is more than one angle here, so don't just use a single letter. If we're talking about this shaded region, you're going to have to name it side, vertex, side. Which side would you like to use first? Pick a letter. What letter are we going to use first? L. Somebody said L. There's only one other letter you could have used, which is M. So let's go ahead and start with L. Angle, L. Give me the next letter. J. Nope. Side, then vertex, then side. What's the vertex? LK. What's the shaded last side for the shaded? LKM. That is the name of the angle. And this is the same angle which you could have also said angle. Start with a different side. What's the vertex? Good. What's the other side? They are the same angle. You could have said either one. There is one other way to name this angle, and it's rare, but sometimes they're going to throw in a number like they did here. See how it has the number 1? When you see it on the inside of the angle, this is also congruent to angle 1. 1 is not the vertex because it's not a point. 1 represents the distance from this side to that side. So we could also call that angle 1 here. It's rare, but it's used in this particular case. Okay, there are 4 different types of angles. Types of angles. I'm going to underline that. Types of angles. There's this type. Acute. That's a cute little angle. There is a right triangle. There is an obtuse angle. And there is a straight angle. Acute, right, obtuse, and straight. It's an acute angle if it is less than 90 degrees. It is a right angle if it is equal to 90 degrees. Exactly. Obtuse is greater than 90, but less than 180 degrees. There's an easier way to write that. I just kind of should have wrote it a different way, but that's fine. And straight angle is equal to 180 degrees. Which reminds me of a pretty lame joke that somebody once told me. If you ever get cold, just go to the corner of the room because it's always 90 degrees there. Oh, I warmed up over here. There you go. Wah, wah, wah. Yeah, math jokes, I'm sorry. That's the best you're going to get. No, that's not even the best. I got some more that are a little bit better than that, but we don't get much better than that. Let's just go with that. Okay, so what you're going to have to do is you're going to have to make decisions on what an angle is based off of a protractor. So you're going to have something. I'm going to give you an example. I'm just going to draw it off over here. You're going to have something like this. I'm going to draw a nice straight line if I can. I'm going to draw an angle this way. I'm going to draw an angle this way. And then I'm going to draw an angle. Let's go like that as well. Go like this, like this, like this, like this, like this. And I'm going to start naming these things with some letters. And the way they do things in math, they usually start R, S, T. They skip vowels for whatever reason. R, S, T, V, W. And usually the vertex will be a vowel for whatever reason. We'll make it the letter U. Supposed to be a capital U, but I don't want you to get confused, so I'll put it like that. I'm going to slide this over just a little bit. Okay, so let's pick out an acute angle. An acute angle here. If I said angle TUV, angle TUV, T, then U, then V means this angle here. Is that acute? Yes? Yes. So next to my acute, I'm going to put in a, for example, I'm put an example right here on the left side. Acute is angle TUV. Side, vertex, side. I have to label it that way. Remember what I told you about geometry. The way you write something is how we tell if you're right or you're wrong. If you write it the wrong way, I have to mark you wrong because you're not writing it the proper way. Okay. A right angle. I don't know if I said this or not, but a right angle, the only way you can tell if something is a right angle is if there's a right angle symbol. This is the right angle symbol right here. The right angle symbol is a little box in your drawing. It means that that angle is a perfect right angle. It's a perfect 90 degrees. So let's give me an example of a right angle. What would you name this angle here? Go ahead and say it out loud. First letter is T. What's the second letter? U. What's the third letter? W. You are correct if you said T-U-W. There is another one there. You could even say this other side, because if this is 90, then the other side is going to have to also be 90, because 90 plus 90 equals a straight angle of 180 degrees. Okay, I need an obtuse angle. Greater than 90, but less than 180. And I want you to start with the letter S. What's the next letter? Say it. And the last letter. You could say V, you could say W. Both look greater than 90 degrees. I'm going to put W is fine. You could use both examples if you would like. Then a straight angle. Here's an example. Let's start with the first letter, W. What's the next letter? U is correct. What is the last letter? There we go. You could have also said R-U-W, angle R-U-W. That would have been fine as well. Okay. If you have to use a protractor to measure something, okay, we are going to use protractors today. What you have to do is, this is how you measure an angle. You have to start off with one side of your angle is 0. Okay, I'm going to put using protractors. Using protractors is my next little blurb. When we use a protractor, one side of our angle has to be 0. Side equals 0 degrees. We have to start with the 0 degrees. It makes the most sense. Let me show you what I mean. If I were to actually measure this angle TUV. Here's TUV. The way you measure angle TUV is you go and put this little dot on the vertex. This spot right there, the vertex, that's where this little hole goes. And you want one of the sides, T or V, to be 0 degrees. The way this protractor works are there numbers here, 0, 10, 20, 30, or there's another number here, that's the 180 side. It doesn't matter if you're using this side or this side, you will get the same angle, okay? But what you want to know is that when your vertex is lined up, this side that's 0 goes alongside that side, and now I'm using 0 degrees, 10 degrees, 20 degrees, 30 degrees, and I'm trying to figure out where this goes, and it looks like it's a little bit past 40 degrees, and then you're going to say how far past is it? Is it 1 degree past or is it 2 degrees? It's about 41 degrees, maybe 42 degrees. The way I would write that is like this. Okay, here's my example. The measure of this angle, it measures, the measure, I'm going to put is about equal to 41 with a little degree symbol like that. That's what my angle is about. It's about 41 degrees. Okay? So, for example, coming back here, I'm going to do angle SUW. SUW. I line up the vertex with U. I have the W and I'm on 0 degrees. So I know that if I'm going from W to S, I'm going 10, 20, 30, 40, 50, 60. I'm using the inside. So now when I get to here, I'm at 150, 155, probably a little bit more than that. It's about 157 degrees. I'm trying to figure out where does this line touch. If you want to be accurate, feel free to extend your line. This line here, I'm not changing that angle by making it longer. It actually makes it a little easier to read. Remember when I said earlier, what did I say it was probably? 150 what? 51. This is 50, 51, 52. It looks like 53 to me. 150, no wait, I'm sorry. 155, 156, 157. I'm looking at like 158 degrees. It's about 158 degrees. I'm approximating at this point. You will use protractors today to do your worksheet. It's fun to practice. But on your quizzes and tests, we will actually have a picture of a protractor, and you will be able to do it from there. But it's good to try some of that stuff. Do we use protractors today? Well, hang on a second.
We use protractors on the back.
Do we do it on the back? Oh, yes, there it is. Thank you. Okay. So then we are going to actually have to do some practice problems. Let's show you how number 15 looks. Number 15, do I do 15 or 21? 15 and 21. I'm going to put over and flip this page over real quick. Almost done. Number 15 looks like this. Has a little picture. Oops, that didn't come out very good. We'll do it like that. F, G, H, and I. 9x minus 8, 9x minus 8. 3x plus 6 right here. 3x plus 6. Then it will say something like this. The measure of angle FHI, that means the measure of is 142 degrees. The two questions it's going to ask you, what's the measure of angle FHG equals blank? What's the measure of angle GHI equals blank? So you're going to actually have to use a little bit of common sense in some of these problems. If they tell you that FHI is 142, they're telling you that FHI, they're talking about the big angle from this side to this side is 142 degrees. Hang on, Ray. This whole thing is 142. So you have to come up with an equation where you use the 142 and you use the 9x minus 8 and the 3x plus 6. I'm hoping you know what it is. Ray, do you know what the equation is?
Oh, yes. 12x minus 2 is equal to 142.
Okay, I don't know how you got the 12x, so tell me what you did before you got the 12x.
3x plus 6 plus 9x minus 8.
That is much better. Thank you very much. He's taking this angle here, and he's going to add it to this angle here. This angle plus this angle should equal the whole angle, 142. This is called the angle addition postulate. You will not learn the angle addition postulate now, but it's something you will learn in Math 2. And right now we're just using what we know. This piece plus this piece equals the whole piece. That's what we're trying to do. Let's figure out what x is. And then what Ray did is he said 3x plus the 9x. He already figured that out for us. He said 12x. Because they're on the same side, just put them together. What's plus 6 minus 8 make?
Minus 2.
And then you add the 2.
X is equal to 12.
And we can figure out what x is. Notice, even though we have x, we still have not answered the question. The question says, what is FHG? FHG. And we have a 3x plus 6, but we don't have how many degrees it is.
Yeah. This substitute 12 is so whatever minus 8 and
Would you use a calculator for most of you? Do you know what 3 times 12 plus 6 is? What is it?
42.
Okay, so then I'll put down over here. 3 times 12 plus 6 is 42. And that is the measure of angle FHG. That's the answer to our first question.
And then DHI is whatever minus 8.
Okay, Ray, don't shout it out, please. We gotta let people think. You can do one of two things. You can either plug in the 12 into that spot, 9 times 12 minus 8. Or, since you know that this angle's 42 and the whole thing's 142, could you figure it out that way too? What's this going to be anyways? It's going to be 100, is that right? And that's the measure of angle GHI. By the way, the little m stands for the measure of, means it's going to give you a number for that particular spot. There's going to be a lot of problems like that. I'm going to stop your notes right there. I think if you understand that, I think you should be able to do the rest of your problems.